Hi, good morning, everyone. Good to see a lot of people are coming again. Thank you for joining the webinar, Tips and Tricks with 3D Printing and Practical Overview. For the ones who don't know me, my name is Jeroen Kleinsma. I'm the digital specialist and a certified dental technician and work for the company Dental Access. I am going to give this webinar because there are still some tips and tricks that might be really helpful during the entire process. And I'll take you step by step through everything with 3D printing. I know a lot of you already do printing, but always it's good to see and hear some different tips and tricks. Hopefully you can definitely use it. So let's give it a start. I want to go through the agenda. So first of all, the introduction of 3D printing, the different types of 3D printing technologies, some designing tips and tricks. Then we're going to talk a little bit about nesting on the build platform, on your software, also with some tips and tricks. Common sense and safety, something about the printing, the aftercare, and the post-processing, also some minor tips and tricks. So if everyone is ready, we'll definitely give it a go. And I want to say the introduction to 3D printing. It started basically a long time ago. But what is actually 3D printing? 3D printing is building an object by stacking layer on layer, where the X and Y dimensions determine the accuracy, and the Z dimension the smoothness and details. So building up. I'll show it more in this picture. If you look at the top right, you see the two cones, basically half spheres, and you see layer by layer being built up. So let's talk a little bit about microns, because everyone is talking about microns. Yeah, my printer does so many microns. I need to print so many microns. What does it actually tell? All the microns we're definitely talking about when we're talking about, yeah, I want my prints to be like this quality, we're talking basically about the layer thickness on the Z dimension. That's basically the Z angle upwards. It's how much it stacks up, the vertical one. It is very common that the layer, the thicker the layer, the fewer layers are required to build to the specific height. You can imagine if I have thicker layers and I build up, I get faster, quicker to the end result. If I have smaller layers, I have to make more layers, expose more layers to get to the same height. But be aware that the more layers you have, the longer the printing time. It can be having less details. It's not completely true. The less layers, the less detail I see in this one. Sorry for that one. So on the right side, we also see something about the large layer thickness, fine layer thickness, and adaptive slicing. Some printers are able to do adaptive slicing. All the printers we work with is basically standard. It's just from beginning to end, same layer thickness. But we have, for example, a Dekima printer that prints the plungers and the objects. The plungers go really fast in 200 microns, so it doesn't need a lot of details. And after that, it changes the layer thickness, more layers, more accurate. So that's more about adaptive slicing. I want to take you also about different types of 3D printing. And these are not all of them, but the most known. We got the fused filament fabrication, FFF. That is basically with a wire, so the Ultimaker systems. So what it is, it's got a wire system. A wire goes through a heated nozzle and prints the object basically layer for layer. The other one is selective laser sintering, SLS. That's, for example, a Renishaw printer that does the RPD frameworks, the metal or the chrome frameworks. There's quite a new technique. We got the stereolithography, SLA, the Formlabs, with the laser. We got the curing bath laser, the same. And we have the digital light processing. And that is basically by a projector. So if we see SLA and DLP are a little bit similar, just the light source is the biggest difference in that one. Like I said before, the Formlabs uses a laser source. So it uses the laser, goes through the object, DLP uses a projector and immediately puts the entire build plate on it. But with digital light processing DLP, we have two different types of printers. We have the bottom-up, all the ones we actually know, the Sega, the Rapid Shape, the Structos. You got a resin tank underneath, you got the light source, you got a build platform that is basically touching the resin tank or just above. It cures, pulls up, goes down, waits a second so the resin can rest and have the equal layer thickness, cures again, pulls up again. So same trick over again. The other one we have is called a top-down printer. That's basically you have a bigger resin tank. You have the build platform that is at just below surface level. We got the projector or the light source on top. And what it does slowly, the build platform basically goes into the resin tank. So goes down, goes up, waits, exposure, goes down, goes up, exposure. And that's, for example, the Gizmo 3D printer. So I'm going to talk a little bit more about the DLP, but that's because that's the most common used next to the Formlabs printer. Because what's digital light processing DLP for dental? And why is everyone now talking about the 385 nm UV? That is basically the wavelength, the UV wavelength. It is just that 3D materials cure faster and with a deeper penetrating UV wavelength, the 385. So it reduces the X and Y scattering and you don't have so much overcure. The result is very consistent, accurate. You can produce very reliable. And the main thing about printing with a 385 light source is that you have water clear material. So when you have a night guard and a surgical guide, for example, those are clear materials and you want them as clear as possible. You need that. For example, what you see on the screen also is, again, from the Chemotrix, is very clear material. You want it very fine detail, you want it very clear. And so it's very important that you have the 385 range for biocompatible materials. It's also the requirement. Well, I'm going to talk to you a little bit about, like I said before, the designing. There are different ways you have to think about when you design a model. How are you going to produce? So when we have models, you can understand that if we have a model for an appliance, for like a clear aligner, you don't need the entire height of the model. You just need the gingiva overflow, basically where the gingiva starts. So if you can see on the top right, you don't need a very high model. This saves a lot of time and material. But if you're working for a crown and bridgework model, you sometimes need more information. So it really depends on what kind of model and what kind of appliance you're going to make. So design models at the necessary height. Think about that one. If you can hollow a model, because it saves material, but it adds design time. Hollow models are really good for just normal crown and bridge work, but for clear aligners, for example, it's a little bit more complicated. I go into that a little bit later. When you are, for example, creating a hollow model and you want to print it, you have to also think about how you're going to print it. Are you going to print it flat? Are you going to print it in an angle? Those things we're going to a little bit later, but therefore you also need to know what do I need to create flow holes in the resin to let the resin flow and the air go in and out the model so you don't get a negative vacuum. The other one, like I said, solid, small models. Do not design unnecessary overhangs. We see quite some unnecessary overhangs, especially when we're going into the next step, and it's basically the names. Preferable to intrude the names on the model, because if you extrude your name, you create an overhang. An overhang can create a failure in print or loose particles that can flow into your resin tank. Your build platform goes down, it pressures all the way down on the Teflon of the resin tank, and it perforates it, and you got a leaking tank. So you don't want to have that one. So because that's a lot of time, money, frustration. Another one is creating distal bars for printing vertically or for stability. Let me go, by the way, sorry for that one. We got some more pictures with it. The intruding of the name tags, the overhangs. Here again, create the distal bar for it. So stability, or you have a printing surface that's flat, you can put your models up vertical. And if you're printing flat on the platform, and a good thing is to design a wedge on the side of the model, so you can scrape your spatula underneath and pop it off. One of the things I said, it's very important to think about where are you going to use your model for, what's the use of it, or your print object. If we're talking about models, we also have to think about wall thickness. You can imagine if you've got one layer, yeah, it will collapse. If we have to make something strong, we have to increase the wall thickness. And so are we going to do, for example, a vacuum forming on top of my model, my clear aligner model? If so, yes, it needs to be as strong as possible because it's still quite a lot of pressure going on top of it. If you have a hollow model that's just 1 millimeter thick and you're doing a vacuum forming on top, yeah, the chance is very big that it crushes and it breaks your model. So therefore, think about how much force it needs to handle. So think about that. Sometimes, yes, adding a half a mil or a mil, you think, oh, it's extra material. But yeah, if it fails during your process, it costs you more printing a new one. So let's talk a little bit about the nesting, the positioning on the build platform. And there are different ways how we can do it. We can go into horizontal, like we see on the top one on the splint. Sorry, not that one. On the models, you have models you can, there it is, sorry for that one. Models you can print flat or on supports. I'll show that later in a small demonstration. We can go print vertical. And do we need that directly flat on the build platform directly, or do we want it on supports? Do we want a ridge on it? There are different ways how to do that. You can print on an angle. One of the things, and I'm going to show you also later, is about avoid cupping, the negative force, and avoid high peel force, what's causing delaminating. And high peel force is basically when you have a big object that's flat and you have your build tray, and the bigger that the object is and it's flat, the more force it needs to use to peel it off of your Teflon. And so your build tray is pulling and pulling, and it has to release from his Teflon from the bottom of the build tray of the resin tank. And if there's a big item, it needs much more force. So the chance might be you get delamination, and that are those openings you sometimes see on models. One of the things with nesting is, and this was about the position, one of the things we have is the supports. It's very important to think about where am I going to place supports. I need to minimize the supports on a fitting surface, or even better, having none, because you don't want to cut that away. Everything you have to cut away takes time, inaccuracy. So make sure there are no supports also on critical required surfaces. For example, on the top right picture, you see the one is there's a connector or support pin on the margin line. And that's absolutely something you don't want, because that's going to damage the margin line, and then you have an inaccuracy. Also think about the support Diameter. If I have a very big object that's big in volume, big in weight, yes, does it make sense to have really tiny support connectors? Probably not, because that's the chance that it peels off or breaks off is much higher. So increase that number a little bit. And also the quantity with the size of the object. If you have a big object, make more supports. If you have a smaller light object, you can minimize the amount of supports in the diameter. The average is 0.4 to 0.6 for a tooth model or a surgical guide. One of the things is make supports overlap with model. Some programs do it automatically, some programs you can adjust it. What it basically is it tells me if I have, let me say, I hope you can all see, I got a paper, I got to connect. If I have a really thin, look like that, a really thin connector, you can imagine, yeah, there's a very big chance it breaks here. So what it is, it tells me, I'm going to do it there, it penetrates a little bit more. So it's called overshoot, and it penetrates the model more. So I have a thicker connector on that side. But it's very important to think about. And set support on each lowest spot. The lower the spot is, there it starts building up. So it needs to start being connected and supported from that point. Otherwise, there's nothing to support. So yeah, you can't print in mid-air. So you need to start to support on the lower spot. One of the tips is have bigger and heavier parts closer to the build plate. You can imagine if this is your build plate and you have the heavy part all the way up here on the top, there's a lot of force going, a lot of weight on those top supports. If you do it the other way around, so heavy part there is already printed, and everything that goes on top of it doesn't weigh so much down on the rest of the object, so you've got less warping. And support all your overhangs. That's something I'm going to demonstrate a little bit later also. With all these things in mind, we have to think about really one thing, especially if you want to optimize your workflow. And if we come out of this horrible time at the moment, one of the things we're all, of course, are going to look more carefully in is how can I optimize my workflow, reduce my manufacturing cost. So we have to really think about, if I spend a lot of time in my designing, because time also costs money, does that make sense in just spending 15-20 minutes more on designing something that I can save basically a couple of cents in resin or in printing time, those things? Is that really valuable? So this one I find always time and price efficiency in balance. It needs to be in balance. So my time against my cost, can I bring it more closer together? Can I reduce the working time on it, designing time, nesting time, and just give it a go? And it costs me a couple of cents more, but I can do other work in the same time. I would love to give you a small live demo. I have two options for that one. One of them is I want to go quickly into the model builder to give a little bit more information, and one of them is going into the nesting for the slicing, basically for the 3D printing. So we talked about creating models. Now, this is the model builder of 3Shape, for example. I have an intraoral scan. I cut away what I didn't want it, basically the base, and I have my information, my text. What I do here is I say a text depth, and I make that a -1. So that will mean it will be intruded instead of X. So we don't create overhangs. You can't see it in this stage yet because it's just sticked on. But one of the things that not everyone knows is if we go up to File and say Virtual Trim Settings, then we have extra settings for the model. And I'm just going into the model manufacturer. And we can say hollow the model. We have a surface thickness, so that's how thick your surface will be. Like I said before, think about what am I going to do with it? Do I need to increase that one? Yes or no? Variable thickness, so it's a little bit variable, so it doesn't go all the way in the tip of the teeth, so it doesn't make sense. It just makes it much as possible everywhere the 2 mil or goes up. Bottom drain hole size. I've already put the settings on hollow model, but if you put this one up, you can create even a raster on the bottom a little bit. One thing that was very important that I mentioned before was the drain holes to let the resin out and air go in and out to avoid having cuppings or negative vacuum. So when you pull it, you pull your object from your resin tank, from your tray basically, that there's not a negative force, a negative vacuum that keeps pulling and pulling and pulling more. Well, there's also unnecessary, so you also get another delaminating a possibility or a fail in print. The height of the drains, the diameter of the drain holes, and how far they are apart. So I've already put those settings in, and I want to say okay. And I'm just going to show you a little bit what it's going to do. So it's going to merge basically my name tag and the model. It takes a couple of seconds. See, it's 10% at the moment. So there I have my name, and as you probably can all see, it's all intruded. I have created here a little wedge. You can do that by going to Final Sculpt, and there is here the plane cut setting. So I can say I want just I have to say the other way around. So, and now I created another wedge. That's like that. If you have print flat on the build platform and you need to put something underneath, you can easily flip it off, basically like that one. So if I am fully satisfied with that one, I go next, and I already selected, of course, I want my model hollow. So if I go to the next step, it prepares my model and it's hollowing the model. It says on the bottom, you can see hollowing models. Also, that takes a little bit. So the more you do in these stages, the longer it takes. Does it always make sense? You have to realize that for yourself and see till what certain point you're happy doing that. A couple of more seconds. Also, like this one, I did not need to create a very high model. If you're having, for example, an implant model with a print model analog inside, you need, of course, the certain height of the model to fit your model analog in there, your lab analog. So that means your model is going to be higher, and that also has different settings. How tight is everything going to be? All those settings you can luckily adjust in your CAD software. And not every setting works with every printer or every environment the same. So that's something you have to test and see what really works for you. It also says my models have been saved. If I change it, I see here my flow holes, basically where the resin can flow out and where my air can flow in and out where needed. And my model is hollow. So this is a very simple step in showing how can I just adjust my settings for making a model. One of the things I would love to show you now is going into the designing or basically nesting in a slicing software, in a printing software. For this one, I'm using the preform, and the reason why I'm using preform to show this demonstration is it shows very well the printability and if everything is supported in the right way. What I'm going to do is I'm going to put in a case. I'm going to say open, and I am going to say I want a flat model. So there I have my flat model, and it's already flat on the build platform. It says on the right side printability, there's an error, there's no supports, minimize supports, but there is no show cusp. And cusp is basically the negative force. If it has a negative area in it, it creates a negative vacuum. So what we can do here is we can change the orientation. I'll show you also later with another case, but my supports. Because how you print also determines how you want to create your supports. What's very important, how to do that. General settings are overall very well, especially with preform from Formlabs. But one of the things I want to say, I want to be on build platform. And here we have some extra settings. That is, for example, the Z compression correction. What it does, it creates a little thin layer underneath your model to make sure that those layers are 100% cured, but that creates a little bit some kind of shrinkage. And after that, your real print starts. If you don't want it and really go directly from the bottom, you set fine. If the bottom is a little bit different, that's fine. I'll put that at 0. And I say auto generate selected. It does a calculation right now. Let's calculate where do I need to place supports. Because support is always if you have an object and there is an overhang, what I'll show later, that needs to be supported because you cannot print in mid-air. So you have to have a starting point from your build platform, layer by layer, until your object. So what it's going to do now, it's created the supports. It's going to check models for printability. And if everything goes well, yes, it did. It says on the right side, printability, it passed. Show minima, so everything is supported. It needs to be supported, and I don't have a negative vacuum. If I look on the bottom, I see there my supports. They just make sure everything is supported in the right way. So this one is directly flat on the build platform. If I'm saying no, but I have a different type of model, I want to print it, for example, a little bit more in an angle. This is again a hollow model, but that doesn't really matter. We have to think about, okay, this is my model. Nice. And in this case, I have to look a little bit at my attachment, articulator attachment. There is a little angle over here. So if I tilt my model a little bit backwards, so raise the incisors, this one becomes more flat. I need supports there. But because of this is my connector for my articulator, I want as less as connection supports on that one. Still, it says, okay, the most amount of volume closer to the build platform, that's still like this. So what we can do now is we can create here the density. We can put it a little bit lower. I don't want so much. I don't want it on a build platform. I want it on rafts. That is a big plate it puts underneath, or on mini rafts. And mini rafts is just really the support with a little circle on the base, and that connects it to the build plate. But you can imagine this is a model. A model is not the lightest. I want a little bit more heavy connection to the build plate. So I'll keep it at raft. And I put my internal supports on if I need internal supports. In this case, it's not really necessary, but nothing wrong with keeping that on. So it's going to calculate again. Here it says, because it's still calculating, my printability of this one is not correct yet, and the support's not correct yet, but it's calculating that now. And here you can see definitely this is the one I want to show you. With this one, now I have it flat. I have the support over here. We can edit supports by clicking edit. There it sees my support. I click it once and it's going to apply. It does applying support edits, does a little calculation again. And then it's going to check my printability. So I would not be surprised if it now says, well, it's not going to pass because this is flat and not supported. And that's what I really like about this software. It really tells you, hey, is it good enough to do a print? Is it good enough? And yes, it says, yes, I am able to print my model like this. See underneath. And this is the raft, what I said. This is your connection to your build plate. You can even change the height settings, and you can even put the name of your STL on it. If you're doing a couple of prints, it's not necessary. But if you have a lot of print volume, small models, a lot of one build plate, you want to know what's what. Sometimes it's not always on your model, for example. Then you just directly know, oh, this is this one. When you break it out, directly put it in the correct box. One of the things we also spoke about is printing vertical. One of the things, for example, when we are going to print a splint. So I'm going to upload my splint. I have it over here. And I told you a little bit about the orientation. We can say, I can difficultly change it over here, but I can already say, select, this is my base. And this is how I would love to print. Again, supports. With this one, slope multiplier, I don't want my supports going far to the outside. I want my supports as much as front here, if that's all that's needed. The less supports and it still prints, the less work I have in finishing it. And even there again, finishing is fine. So, and again, this is a lot of forced pulling, but I'll just maybe can show you the mini rafts. I have that one, and I say auto generate selected. That's going to calculate the new supports for this one. And it also depends on your material. Some materials are better to print with minimal supports, and some of them just need a little bit more supports. So it depends on your material, on your printer, on your surroundings, how to do your print. I know a lot of you have a lot of printing experience already, so that's really good. But it's never wrong to, if you have the time, and again, time is money, but if you know what you're doing with your machine, with your materials, it in the end saves you money. And here I have one that's like that. I see, for example, one support over here. That's something you don't want on a fitting service. I remove that one, say apply, it calculates, and it calculates again. And then hopefully again, my printability will pass. And again, I can print like this. So I have minimal supports. But like I said, the mini rafts is just support with a little cylinder around it. You can imagine if my build plate pulls on my resin tank, if this is my only connection to the build tray, it is not much. So the chance that it detaches, delaminates is very big. So even with these things, I would definitely go for the normal rafts. We spoke a little bit more about overhang. Let me load another model that's a little bit more clear. And I'm not going to save this one. I'm going to open. This is nothing to do with a dental model, but it at least tells you a little bit more. Everything going that way or going that way connected from the build platform is fine. But here, how am I going to print this part here and even the tail? There is no connection because I can't print backwards. So you need to say to the system, hey, if you want to print this object, you have to start here. And again, this is your support like that. I'm going to do it directly on the build platform, and I'm going to say auto generate selected. This one should go a little bit faster. And most of the printing software we have nowadays, really good calculating software. It tells you exactly, okay, I need to support that. There's an auto generate function in the software, but sometimes you just want to change. Here it tells me exactly, okay, I need to have support on these items. If you're like, yeah, but I do not fully agree because it still says, oh, it is, for example, red in the software. Again, you can add it over here. And what it does, it will select all my points. By clicking on one, it becomes red. If I click on the left mouse button, it will be deleted. There it is. If I want to place one, I just put on an empty space and left mouse button again. And there is it. And then apply. So you can remove, you can add how you want to do it. So that's a little bit about the nesting. So think about how do you want to nest? What kind of supports am I going to need? And the software likes it basically really good, but you can play really well with it. So if I'm going back to my presentation, so this was a little bit the live demonstration. So if I hit the print button and then I've printed an object successfully, what are we going to do next? Well, of course, remove the object by spatula. We found out that if you have a really thin spatula like this, you can just get it at any hardware store, like a Bunnings, for example, what we call it here in Australia. This is a really flexible tin, so make with a scalpel or another object, little opening, put this one, slide this under, and it comes clean off your build platform. One of the things after when it's done is you have to make it really clean. You have to check if there is nothing left in your resin tank. There are a couple of options in doing that. One of them is doing that with a spatula. Be very careful, especially with a sharp spatula, that you don't damage your Teflon on the bottom of your resin tank. So wipe it around carefully to see if there are any cured objects that might be in there and that might penetrate your Teflon with the next print. So you can use a spatula, or you can even print your own comb. There are on internet a lot of STL files available. Print your own comb, run that through your resin tank, and you know if you have any particles left. Another thing is some printers have the option to do an exposure thin layer and peel that one off. With that one, you basically trap the remaining particles like dust, hair, cured resin, and then you peel that immediately off. And that looks like this. So that's a really thin layer. You can peel it off, and everything that was still laying on the bottom of the resin tank is entrapped. You peel it immediately off, and your resin tank is clean, or at least there are no particles left in your resin. So we talked a little bit about common sense and PPE. Yes, common sense. Use, for example, when you're having a printer, and that's even the same with the scanner, have that one on a stable surface. Nothing that's wobbling, or when you walk around that it vibrates or anything, because you can understand if it's doing a delicate job and it vibrates or it moves a little bit, your print is not that accurate. So use a stable table or surface. Use an easy to clean surface. Yes, it's beautiful if you have just a beautiful wooden unlaminated table, but if resin falls into it, it's difficult to clean, you get stains. If you have a metal plate, stainless steel, for example, easy to clean. One of the things that's very, very important is a well-ventilated area. You have to imagine if you or your staff members or a member of your team is working in an enclosed area that is not well ventilated, and all those fumes from the resin, from IPA, whatever it is coming in the air and breathing it all the time in and out, well, you can understand that's not really healthy and pleasant. So make sure you do it in a well ventilated area. That's just very important like that. Some people even have a rain chute above their printer, so that's even possible. One of the things is don't put your printer or your resins in direct sunlight, because it's UV hardening resin material, liquid. It will harden already by normal daylight, by sunlight. So avoid that in directly sunlight. Wear safety goggles. You can imagine if you're working, you take an object off, it splashes a little bit or whatever, you don't want to have any resin in your eyes or small particles. Also wear nitrile hand gloves. Preferably not having a latex, because latex can have a reaction with the resin liquid. Use a lab coat, for example, to protect your own clothes. You don't want, I mean, wearing a nice white shirt and it gets all ruined by spoiling some resin or IPA or whatever on it. So just use common sense, like what's normal. You don't have to crazily overdo it, but just be aware. Again, well ventilated is so important. We had a successful print, but what are we going to do then? As we had a successful print, took it off the print platform, cleaned to the print platform, but the next step is how do I make sure? So with a spatula, clean it, wipe it with IPA. And one of our really good tips is take your build platform on your bare arm and rub, basically slide it on your arm, because the skin on your arm is very sensitive. So you directly feel if there is something still stuck to the build tray, which you haven't seen, for example. But that's a really good trick to use. Like you're really sure, okay, that feels smooth. Fine, I am sure that my next print will be possible. So if I took my build object, my object off the build tray, we have to clean it. And it also depends, of course, on the material again. A lot of materials you are able to use an IPA, isopropyl liquid, basically pure alcohol. Or some materials say, yeah, but you need a water. So be aware what your material is, what you need to do. Also, there are so many regulations. Again, it is your own duty to make sure that the material you're using is allowed in the country you're working, or where you're working with your patients or with your clinicians. So check that very carefully. All the information about the materials your suppliers have. We have an entire list from every material, how to treat it, how to work with it, and instructions for use. Like I said, if we clean the object, there are two ways. We can have a washing unit, for example, do a foam wash. It's just a tray, you put it in, it centrifuges, it rotates, and it cleans with the IPA, it swirls around it. Another one is putting it in an ultrasonic bath. Take, for example, a plastic takeaway box, fill that one with IPA, put it in the ultrasonic that has been filled with normal water, put it in, let it go for 3 to 4 minutes, blow dry it basically, put another clean container with clean IPA and do the second run. So you got a dirty container and a clean container like that. When it's ready, when it's cleaned, we of course need to finalize your light curing process to make really sure everything is 100% light cured and that you got a stable object that will not warp or is still tacky, sticky. So what you can do is there are again different light curing equipment. One of them is the Form Cure. One of them is, for example, the Autoflash. Autoflash is a machine that's more suitable for biocompatible materials. It uses nitrogen gas, so it basically removes all the oxygens. You get a more dense cured material, and it penetrates also better. So you get, like I said before, in the biocompatible materials, you get a more crystal clear printed object. And when you are light curing it, it's just better to have 2 shorter sessions than 1 longer, so it doesn't overcook or burn the material. Because normally it's about average 15 seconds for an exposure. There's no exposure. An exposure, there's no exposure during printing. And if you now have for the full 5-6 minutes or whatever it takes for your material directly full UV light, you can understand that it generates a lot of heat and you can have overcooking and burning. So that's one of my tips: do shorter sessions, let it rest, do another session. But always you need post-processing for a final result. One of the things I really want to mention also is no workplace is the same. Again, think about ventilation. Every room ventilates different. You want to be in a clear, clean environment. The surrounding temperature also influences your print. Most of the printers have a heating system, so they say between 30 and 35 degrees. I heat up my liquid and it flows really well, and with that one I can do a successful print. So if you're in a cold area and it's been freezing the entire night, for example, or it's been very cold, and the next morning you come in and directly want to go run a print, yeah, your resin might be still very thick, or your machine is not heated up yet, so it's very unstable. So those things you have to think about, surrounding temperature influence. And again, using a stable surface, nothing that moves, so you make sure when you walk by or you touch the table that it doesn't wobble all around. And yeah, please don't take shortcuts.